Welcome to Math Prowess. Today before us we have a challenge. Now if you look at the question reads 2 to the power of x plus 3 to the power of x equal to 5 to the power of x. What is the possible value, the real value of x? Now if you look at this question at a glance, you can tell the answer, the value of x. X is equal to 1. Because if you put 1 here, this will give us 2. Put 1 here, this will give us 3. So 2 plus 3 will give us what? 5. Because if you put 1 here, this also gives us 5. So 2 plus 3 is equal to 5. But supposing you are giving this question in an examination hall and you have to show that the value or the only real value to x is just 1. So how do you solve this? So we're going to solve this using some proofs to show that the only real value or real solution to this challenge is just 1. So if you're new here, this is Math Prowess, where we'll learn mathematics all the time. If you've not subscribed, do it to subscribe so that when you subscribe, you get notified whenever we drop amazing video, because on this channel, we drop amazing videos all the time in mathematics. We're going to review some tricks in solving math challenges of different categories. So you're welcome. So let's take our solution here now. So we have here solution, that is the first, according to Steve R. Carvel. So the question, let's take time to solve this question step by step. So 2 to the power of x plus 3 to the power of x equal to 5 to the power of x. So what is the first two we're going to do here now? We're going to divide through by 5 to the power of x. Why? That is the highest value. So let's divide this by 5 to the power of x. We equally divide this by 5 to the power of x. We divide this by 5 to the power of x. Right? Good. On this side, we're going to have 1. Now, we apply the law of indices, okay? Because the exponents are the same, but the bases are different. So we can rewrite this and this. So rewriting this will now give us what? So we're going to have here 2 all over 5, right? All to the power of x, then plus 3 all over 5, all to the power of x. This is equal to 1. All right. Now, with what we have here now, what do we do? So we let the function f of x be equal to everything we have in here. In other words, we move this one to this side of the equation and express it in the form of f of x. So we cannot say here, let our f of x, the function f of x, be equal to 2 all over 5 all to the power of x plus 3 all over 5 all to the power of x, then minus 1. Because we're moving this to this. What is the next thing we do here? It is very easy. So we differentiate this function with respect to x. So let's go ahead and differentiate this. So our dy, or let's use the word f prime of x, or we can equally say dy dx, okay, is equal to, bracket 2 all over 5 all to the power of x ln of 2 all over 5 plus your 3 all over 5 close bracket, okay, all to the power of x ln of 3 all over 5. Correct. Now, with what we have here now, again, this will turn to 0. We all know that if we differentiate a constant, that will give us 0. So this gives us 0, right? Now, if you look carefully, you discover that both ln of 2 all over 5 and ln of 3 all over 5 are negative. Okay, if we find the value of these, they are both negative. Again, 2 all over 5 to the power of x and 3 all over 5 to the power of x are greater than 1. True or false? Okay, let me put that down. So we have here 2 all over 5 all to the power of x and your 3 all over 5 all to the power of x are both greater than 0. For every real value of x, okay, for every, let me put it, you write it so that you don't get confused, for every real value of x. Then, if these conditions are true, that this and this are negative, then and your 2 to all over 5 to the power of this, 3 all over 5 to the power of this belongs to a set of real number. Therefore, what does that mean? It also means that our f prime of x, which is the differential of x as a function, is less than 0. True or false? So it means this is less than 0. If this is less than 0, what does that tell us? So it means that f of x is strictly increasing function, is strictly, sorry, decreasing, is strictly decreasing function, strictly decreasing function. Okay, so if this is strictly a decreasing function, and a strictly increasing or decreasing function can have at most one real root. Take note of this. I repeat again. I said, for every strictly increasing or decreasing function, we can have at most one real root. So if it is true, therefore, our f of x only have one root, has only one real root. So we cannot conclude that therefore, our f of x only have one real root. Sorry, my handwriting is okay. Has only one real root, and that one real root will only be 1. So it thus means that x is equal to 1. So 1 is the only real root that will satisfy these our original equation. And that is what I told you at first, that 1, just for mere speculation, okay, you can get the answer, which is 1. But how to prove that 1 is the only real root that will satisfy this equation or this expression is what we have done here so far. So 1 is the only real root that will satisfy this expression. Okay, so thanks for being there. And if you learned something from this video tutorial, then give the video a thumbs up. And if you have a better way of solving this, then drop it in the comment section. Or you have a question with regard to the explanation from the beginning to the end of this expression, then leave it in the comment section. We are good at replying to comments. Again, this is Math Prowess. You're welcome. Bye for now.